Hello, this is Dan Evenson. The purpose of this video is to demonstrate my embedded systems board for ECE376 at NDSU. For this homework, I decided to make a roulette wheel using INT0 interrupts and timer 0, timer 1, timer 2, and timer 3 interrupts. So, timer 1, interrupt 0 is INT0 configures that on a rising edge on RB0 it'll interrupt and do whatever I told it to do. So for this INT0, I'll just grab the other ones because timer 3 is a counter that keeps counting to 100 nanoseconds. Is accurate to 100 nanoseconds. Sorry, I think that's, yep. Timer 3 is accurate to 100 nanoseconds. And then at the push of RB0, the interrupt will take a random number. So timer 3 will be timer 3's count mod 37, because for a roulette wheel, there's 37 different possible spots to land on, 0 through 36. And timer 2 controls the beep count. So each time that I press it, it'll count. The speaker will go 10 times. So that reflects the ball going around 10 times, and then it'll stop. And then I'll get a number on the LCD screen. So that is 7 red. So in case you don't know how a roulette wheel works, which I did not at the beginning of this project, the pockets of a roulette wheel are numbered from 0 to 36. A number ranges from 1 to 10 and 19 to 28. Odd numbers are red and even are black. So in this case, we're in the range 1 to 10, so odd numbers are red. And I'll just press it again. And there we got 35 blue. Well, I don't have, 35 black, sorry, 35 black. And that also matches because in ranges from 11 to 18 and 29 to 36, odd numbers are black and even are red. So we are in the range 29 to 36, so we got a black there as well. So that is also correct. And then there's one green pocket, which is the zero spot. So overall, 37 total spots to land on for a roulette wheel. The duration of the speaker beeps is set by timer 0, and timer 0 is accurate to 20 milliseconds. So the duration of those speaker beeps is 20 milliseconds. So one beep is 20 milliseconds times 10 times. So I'll just do it one more time. Hopefully you can hear that. And I got 35B again. So that was kind of lucky there. So I'll just hit it one more time. 20 black. Which that also lines up with my description, because in 19 to 28, even numbers are black. And back to the timer interrupts. Timer 1 sets the frequency of the speaker, which is set to 440 hertz. And then I did some measurements. I don't have an oscilloscope here with me, but I did do some measurements earlier. And by toggling RA0 for timer 0 interrupts, I got this waveform out. So this is 10 milliseconds per division. So there's 10, there's 20. So timer 0 was supposed to be set to 20 milliseconds. So that lined up pretty well with my output here. Timer 1 interrupt measured by toggling RC1. This is the frequency on the speaker output. This was measured to be 437 hertz, which I intended for it to be 440 hertz. So that's fairly close. I would say that's within my tolerance of, plus or minus 10%. And let's go to timer 2 interrupt. Timer 2 interrupt was measured by toggling RA1. This was a little bit off. It was measured to be 25 milliseconds. And timer 2 was meant to be... Whoa, I'm way off there. I am farther off than I thought I was. So that was 25 milliseconds, and I meant timer 2 to be 100 milliseconds. Now, what this could be is, where's timer 2? Timer 2, so I might not have been measuring that correctly because timer 2 is right here. And every 15th interrupt is how I get this. So I might have been outside of the bounds here. I will have to go back and remeasure that to double check. I might have toggled here instead of within every 15th interrupt to get that 100 millisecond timing. So my mistake there. Timer 3 interrupts was measured by toggling RA2. This one gave me a really goofy waveform. It kept bouncing back and forth between these two spots here, so it was either from this line to this line, or it was measured from this line to this line. And I could not understand why it was bouncing back and forth, but it was meant to measure to 100 nanoseconds. And, sorry, not 100 nanoseconds, 100 microseconds. And if you can see, there's 50 microseconds per division. So here is 50 microseconds and 100 microseconds. So that was also within my tolerance, but it just looks a little funny on the screen here. I also did a chi-squared test to see if my number was indeed random. And I divided the numbers, the range numbers, into the 4 bins, so there's 3 degrees of freedom. I found my chi-squared critical value to be 4.67, and that was after 60, I did a total of 60 trials, 60 sample size, and found the frequency for each of those bins. And I found that the probability that this is indeed a random number to be about 80%. So that's, pretty good. I indeed could have had a larger sample size to go from to see if that 80% is accurate, or if it was go up or go down, or see what happened with that. But I hope you enjoyed my video here. If you have any questions, you can email me, reach out to me. Thank you for watching.